Okay, now we're going to look at the second problem on this sheet. It's looking for paths of length, something or other. Okay, back with the glasses. I am going to scoot through this fairly quickly because I'm supposed to get out of here in 10 minutes. All right, here's the graph. A, B, and C. It is a digraph. It's a directed graph. A has a loop to itself. B has a loop to itself. A and C go back and forth to each other. And B goes to C and to itself. Okay, so 1, 2, 3, 4, 5 arrowheads. They're kind of ugly. Sorry about that. Bit of a hurry. But we want to find, according to the directions here, we want to find all the paths from A to C, vertex A to vertex C, of length 2 and length 4. Now, before we do that, we're going to set up what's called an adjacency matrix. That was the vocab thing that I erased and said I'd tell you about it later. An adjacency matrix. And that's going to look like, okay, over to the left here, I have the vertices lined up. You see that okay? And then across the top, just right here. Make sure you can see it. Okay, now this is the from side, and this is the to side. The way we're doing the orientation for our vertex, for our matrix, is that if the path goes from A to B or to C or A, whatever, then we're going to give it a 1. If there's an edge there, if there's an edge from A to A or from A to B or A to C, we're going to give it to 1. From A to A, that kind of thing. Well, we look at the graph and we see there's a vertex from, see this one here, the loop, from A to A. So we're going to put a 1 there from A to A. There's nothing from A to B, so we're going to give it a 0. Okay? And then there is one from A to C, so we're going to give that a 1. Okay? This is how you make this. One of the most common problems, it's one of those no-brainer problems that you're supposed to be able to get right every time, is either taking the graph and making an adjacency matrix from it, or taking the adjacency matrix and making a graph from it. Okay? Just have to be careful, be very detailed, and try not to miss those, because those are supposed to be gimmies when you're doing the worksheets and the quizzes on those. All right, so from B, we do not have an edge from B to A, so we give it a 0. We do have an edge from B to itself, so that gets a 1. And then from B to C, we have 1, so that gets a 1. And then from C to A, yes. C to B. This looks like we might, but we don't. The direction says no. Okay, it's going from B to C, not from C to B, so that gets a 0. And there's nothing from C back to itself, so that's a 0. So this is our adjacency matrix. Now note, if there are 5 arrowheads here, 1, 2, 3, 4, 5, then there should be 5 1s in the graph. And that's what we have. Okay. So this is M. Specifically, it's M1. Okay. Now, what we're going to borrow from algebra, from second-year algebra, is matrix multiplication. And I'm going to kind of rush through this. This is a review concept, hopefully for most of you. And let's just do it. Why are we doing it? We're squaring the matrix. By the way, this matrix basically shows us all the paths of length 1. All the paths of length 1. What do we usually call those? Edges, okay? These are the paths of length 1. When we get M2, M squared, that's going to give us, it's going to number for us all the paths of length 2. And that's part of what we want in the problem, is how many paths are there from A to C, okay? Well, I'm going to have to give you a truncated version of what I would normally do here, because I'm running out of time and I've got to hit the road. Okay, so what we do is redraw matrix 1. So 1, 0, 1, 0, 1, 1, 1, 0, 0, A, B, C, etc. Now, as you may recall, Better red pen. Let's try this one. As you may recall, with matrix multiplication, it is a row by column operation. So we got these rows and these columns. Okay, and can you see? Yes, you can. So what we're going to do is produce M2, and to do that, we're going to take row one. I'm going to do it slow, sort of slow, the first time, and then the rest of them I'm just going to rip through. Okay, so we're taking row one to get this right here. This is A, B, C, A, B, C. To get the number from A to A, which will represent all the number of paths from A back to itself. Okay, we need to take row A times column A. All right. Now to do that, it's watch my fingers. It's 1 times 1. Okay, now watch my fingers move. 0 plus 0 times 0. Okay, watch me move again. Remember, this is row column, A to A. 1 time plus 1 times 1. What is that? That's 1 plus 0 plus 1 equal 2. And that's what goes here. There are 2 paths from A to itself. Okay, and what are they? Now that we know where they start and where they end, and how many there are, we can go and look at the graph and find out. And we say, oh, one of them is A. So now the path. The other one is ACA. Okay? Now, from A to B, we want row A, column B. So 1 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 0 plus 0 plus 0 is 0. There are no paths that go from A to B. There just aren't any, and there never will be, no matter how many times we multiply the matrices. Okay, that entry will always be 0. Okay, to C then, row A, column C, 1 times 1, there's 1. 1 times 0, 0 times 1, that's 0. 1 times 0, so there's only 1. That was part of the question. How many paths of length 2 from A to C? This says there's 1. We look over here. A, C is the valid path. Now, a path of length 2 is going to have 3 letters because you're not counting the vertices, you're counting the edges in between the vertices. So this is 1, 2. 1, 2. And then A, C, 1, 2, 2 edges. So it's a path of length 2. Make sure when you're giving paths of length 4 that they have 5 letters in them, 5 vertices. It's the edges in between the vertices that we're after. Okay, and then to finish this so that we can move on to M4, or at least I can suggest how you would do it if I have to cut the video off. Okay, B, we want from B to A, so we go B, 0 plus 0 plus 1. There is 1 path from B to A, and that is BCA, and that is valid. Okay? Path from B to B. 0 plus 1 plus 0. There's 1. And what is it? B. Paths from B to C. 0 plus 1 plus 0. 1. What is it? It's B to C. It's going to have to be BBC. Okay, now let's do C. That's 1 times 1, and you can tell that these are going to be zeros. So that's all there's going to be. 1, and then from C to B, it's 0 plus 0 plus 0. And then C to C would be 1 plus 0 plus 0. So there's a path of length 2 from C to A and a path of length 2 from C to C. Let's add those. C to A is going to be CAA. And then we'll do C to C. C to C is going to have to be CAC. Okay? And that's the whole M2. So that tells us we got 2, 3, 4, 5, 6, 7. We got a total of 8 paths of length 2. And there they are. Now, since I'm short on time, I'm supposed to be out of here in 1 minute. I have to cut this short. I wanted to finish the problem, but what you have to do next, okay, here's the question. How would you get paths of length 3 using this method here? Right, you take M2 and you multiply it times the original M. And the result will be M3, and that's going to tell you all the paths, how many paths you have of length 3, where they start, where they end, okay? How would you get paths of length 4? Right again, you take M squared times itself, and that gives you M4, and that will count up all the paths of length 4 for you. It'll tell you where they start and where they end, and you can do the rest by inspection on the graph. Be careful with that, and I hope you were okay with this video. Yay.